would be unfaithful to the state of California. So so we'll just use our calculator for this. So the 8C3. So yeah, if you have your calculator, take it out, just crank this out. So on the TI anyway, it's under what, math? Gotta hit math, and you gotta go to the right like 3 times over to the probability menu, and then go down to the C. So first you hit the 8, then you do the whole math probability thing, and then you hit the 3, and then you hit enter. So you want to get on your screen 8C3. So use your TI, hit the 8 first. So you just go in order from left to right, 8C3. So 8, and then go to the math menu over to probability down to C.
What is this? N big C R.
Yeah, so it's NCR. Yeah, we're looking for NCR. Exactly. You guys getting that okay? I think it is, what is it? It's 8 times, is it 56?
Yep.
I think it's 56, yeah. 56? 8, and then the NCR, and then the 3. And you should get the answer 56 on that with your TI and the Casio. I'm not sure where it's at. I'm sure it's somewhere.
Can you tell me if I'm entering this correctly?
Well, it's right if it's 56. I don't know anything about the 8 and 9 in particular.
What is it look like?
On the screen. Let's see if I do it. Math over here.
Oh, is it that much? I can see that much.
Zero.
Oh, I don't know about the parentheses afterwards.
That's what it looks like.
Yeah, not the parentheses. I don't think. Is it coming out? You guys able to get that? You find it on the math thing? Josh, that work out?
Yeah, I'll figure it. I have the other calculator too.
The 89 is always challenging. All right, we good with that? So for now, that's just like a magic step. I mean, what is that? Who knows? It's actually something in the real world, which we'll get to in a second. But everybody good at cranking out the tool right now? Key button as well. There's these 2 buttons we're looking for, P and C. They're right next to each other. So again, it'd be 8, and then the NPR. Doesn't mean National Public Radio. It means permutations. And it should be 1. The answer is just 1. Anything with a 0 is always 1. Guys able to get that okay? That 89 wouldn't do it?
No.
It looked right what you were doing.
Yeah, it just kept telling me too few arguments.
What's the actual tool called?
Based on I'll use that.
Permutations?
Yeah, for permutations. What's it actually called?
That is its formal name. It's NPR.
Oh,
NPR. Yeah, the NPR. And Josh, where'd you find it? Because you had the thing on the screen. Oh yeah, you got that. Oh yeah. So it's probably you put the 2 numbers right there. So go here. Do
2 comma
2 comma 0 or whatever. 2 comma 0 parentheses. Oh, good. Close parentheses. Yeah, that would.
Okay.
Just put it afterwards. Yeah.
But
yeah,
both numbers afterwards.
Yeah, both numbers afterwards. It always has to do everything different than the regular ones. I don't know why. All the other TIs put it before and after, but not the 89. All right. Anyway, so you guys able to get that on that? So for right now, it's just, it means nothing in the real world, but we're going to get to the real, what is that? Well, we'll get to it. All right. 8, no, sorry, I always make that joke. It just means 8 called factorial. So that exclamation point, the official word is factorial. Anyway, you have a button. It means 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, all the way down to 1. But you have a button. Don't bother to type all that in your calculator. Just hit 8, and then you have the exclamation button. Same place as the other stuff. It's under math probability. So you're going to hit math, go all the way over to probability, go down, you'll see an exclamation point. You had to put the 8 in first, then the exclamation point. Somebody got the numbers real big, right?
That's 40,320.
40,320? Thank you. Y'all able to get that? Kevin's not working on the Casio. Would you find the NPR? NCR stuff?
Kinda.
It's gotta be like look for a probability thing.
I saw this. Man,
Yeah, there you go.
but I don't know how to.
Oh, you first put that. Yeah. So first do the number. So like first put a 10 on the screen and then do the P thing. So just go 10, yeah, or something, or whatever our number, yeah, then go to the P, and then do like 2, and then hit enter, let's see if it's working. Yeah, it's cranking it out.
Okay.
So that'll do anything you want there, P or the
So
C.
that's the same thing for this one?
Oh, and then this one's exclamation, so is there an exclamation? Go back to, oh yeah, there it is, yeah.
Yeah.
So just type in 8, do the 8 first, was it 8? Yeah, 8 and then an exclamation. And hit enter.
Oh, no.
Yeah,
Okay.
good, there it is.
And then what about the C? Is it the NCR?
Yeah, that's the NCR.
Okay.
Good. All right. We all working? And we'll be off to doing something real with them. This will be our last little. Can you do the tool thing? So how about 13C3? Um, 286? 286. Y'all able to get that? 286 with the 13C3. All right, because we're going to use these to do real life word problems right now. Is that coming out for you, Kevin?
I got it, yeah.
Good deal. We're talking about this one, the stereo and the different components and stuff. Okay, the owner of a stereo store wants to advertise that he has many different sound systems in stock. Right. 8 different CD players, 7 receivers, 9 speakers. And that makes a sound system. So basically the question is how many different ways are there to make a sound system? So I think I talked about, like, what if I have 2 pair of pants and 3 shirts? Let's just start with that. It's the same kind of thing. If I have 2 pair of pants and 3 shirts, how many different outfits can I wear?
6.
Yeah, 6, right? Because it's, it's pants number 1 or pants number 2, and along with pants 1 is shirt 1, shirt 2, shirt 3. Along with pants 2 is shirt 1, shirt 2, shirt 3. So there's 6 different outfits all together, right? That little tree is kind of showing the different possibilities. So all you got to do is take 2 times 3, and you get 6 outfits. Right? 6 different outfits, like that. So, all we have to do here is take 8 times 7 times 9. That's what I'm saying. When you have different options, you just multiply them together if you want all the different ways to put them all together. Does that make sense how I'm looking at that question? A sound system, see how it consists of one of each, right? 1 CD player, 1 receiver, and 1 speaker, 1 of each. So just like getting dressed has to do with pants and a shirt at the least, shoes, right? So same thing, you just multiply these things together, and that'll give you all the different ways of putting together. You have 8 choices for the CD, 7 choices for the receiver, and 9 choices for the speaker, different speakers that are available. So there's a lot of different options for how to put together the sound system. You just multiply those together. Somebody have that number? 504? Thank you. 504 ways to put the sound system together. Does that make sense? Just multiply them. So when you have options and options and options, you just multiply them together. Okay, so now, okay, so if a company it has a 5-digit phone extension with the first digit not being 0, how many different extensions are possible? Okay, they're going to ask us a lot of questions about, like, how many ways are there to do this thing. That's what this section is all about. It's one of the main things this section is about, is how many different ways are there to do things. This is useful. Say you have a big company, Microsoft, or who was the other company that was just here a couple weeks ago? Google came. A rep from Google came. I think it was a month ago. My daughter went and watched it. My daughter thought it was funny at the end. Google's real, they're real cutting edge and all that kind of stuff. So somebody raised their hand and asked the rep from Google and said, somebody in the crowd said, I heard that Google might be putting a branch in Fresno, And the lady she paused and she tried to say real nicely, my daughter thought it was hilarious, said real nicely, well, Google likes to go where there's a lot of talent. And I don't think there's any plans to come to Fresno. She said it very nicely. The person had a self-inflated view of who we are here. Anyway, I just thought it was funny. Anyway, Google's in, Simi Valley and places like that, right, where all the tech places are. Anyway, I just thought it was funny. So, big company like that, how do they know if you make up some phone system, are you going to have enough extensions to cover all your employees? You have 50,000 employees. Do you have enough extensions? What if you say, here's our plan, everybody's going to have a 5-digit extension, but we're not going to let the first digit be 0 because that would just be confusing. How many does that cover? You got to know. When they print license plates with the letters and the numbers, how many different ones are possible? Is that going to be enough to cover all the cars? How many cars are there? When they do zip codes, when these kind of schemes are developed, they got to make sure the number of possibilities cover the population that it needs to cover. So it's a math problem, really, and it's needed in the real world. So how do you figure that out? How many different extensions are going to be possible for 5-digit extensions, first digit not 0? How could we figure that out? Remember me getting dressed? It's as simple as that. Pants and shirt. Right, I had 2 pants and 3 shirts. Think about me getting dressed in the morning, right? I'm thinking, all right, got my 2 pants and my 3 shirts. I'm going to get dressed. So I've got to make 2 decisions. I've got to decide on a pair of pants to wear and decide on a shirt to wear. And then you multiply those together, huh? So it's decisions and options. It's decisions and options. First decision, second decision. First decision, second decision. How many options, you put the options up here, how many options are there for my first decision, which is what pants to wear? Well, I just had 2. Oh, yeah, you're doing the real problem. Yeah, we'll get there. Yeah, 2 pair of pants, and how many options when it comes to shirts? 3 shirts, multiplied together, 6 total ways to get dressed. Right? So same thing, yeah, you're thinking right. 5-digit extension over here. You know what helps me a lot of times is actually just to pick one. I took a whole class on, it seems funny, it seems like I took a whole class at Cal Poly getting my math degree. The class was called counting. That sounds great, right? You're looking at the high-level math classes that you need to take to complete your math degree at Cal Poly. And one of them was counting. I thought, well, that doesn't sound too bad. It's just counting. That was one of the hardest classes I took. It was this stuff. And this stuff gets really subtle. It gets really tricky at high level. So, how do you count the things? That's what we're trying to do. We're trying to count how many different phone extensions are possible. That's what we're trying to do. In fact, I give you flavor. That class was so hard that when we got to the final exam, Dr. Hood, I had him for like 5 classes. He's a funny guy. He's always walking around. He always thought we're so stupid. He's like, you guys, what's wrong with you? He was always talking to him. He was hilarious. Anyway, and Dr. Hood said, all right, here's the final. He just gave us the final, a week of it. He gave us 20 questions, and he said, I'm going to pick 10 of those to be on your final next week. Literally. No changes at all. I'm not even going to change the numbers. So do those problems this week. Do those 20, and you'll have the final done. Next week it'll be 10 of those will be the final. Well, it's still way too hard. They were hard. They were really hard. I did what I could. I got a B in that class. I couldn't get an A in that class. The class was hard, really hard. Anyway, counting. It gets really tricky later on. So, 5-digit extension. Let's think decisions and options. This is the first fundamental principle of counting. Think decisions and options. So, and actually do one. Let me pick one. I'm going to pick one of their zip codes here, or one of those 5-digit extensions. All right, 70236. Boom. I just picked one at random. It helps to really do it. It gets your mind thinking real, because this stuff is very real. Be as real as you can. So I just picked one. There's a 5-digit extension that doesn't start with 0. I followed their rule. I picked a 5-digit extension that doesn't start with 0. Now, think back to what I just did. How many decisions did I make? And for each of those decisions, how many options did I have? And then just multiply those together. That's all you got to do. So I made 5 decisions, didn't I? I picked 5 different digits. For my first decision, when I chose a 7, how many options, remember on the line goes the options, right? You put the options on the line. How many options, right here I'm going to put how many options I had. I chose the 7, but how many options did I have to choose from? 9. That was the 9 you were saying, right? Because I couldn't choose 0, right? The first digit can't be 0 right here. First digit can't be 0, it had to be 1 through 9. I had 9. That's a 9. I had 9 options, didn't I? I happened to choose the number 7, but I had 9 different things I could have picked from. That was the first digit. Now, next I chose the second digit. How many options did I have for the second choice, second digit?
10.
I had 10. Because there I could have chosen 0 or 1 through 9. When I came to choose the third digit, I happened to choose 2. How many options did I have? 10 again. And it's 10 the rest of the way, isn't it? Because the other ones can be a 0. When I chose my fourth digit and my fifth digit, I chose 3 and 6. I had 10 options at each of those spots. I only had 9 options for the first digit because I couldn't do 0. And I had 10 options for all the other digits because I could choose anything 1 through 9 or 0. Right? So, just multiply those together and you have all the possibilities, and that's easy to do, right? Anytime you multiply by 10, it adds a 0. So take 9 and add 4 zeros because there's 4 10s there. 90,000 different extensions. That would cover 90,000 employees. There'd be 90,000 different extensions with that scheme. Does that make sense? So it's kind of the fundamental core of counting. Decisions and options. It gets a lot trickier than that, but that's the beginning. Decisions and options. All right. So with that, I'll keep moving. All right. There we go. So license plate tags in a particular state are to consist of 3 letters followed by 4 digits with repeated letters and digits allowed. How many different license plate tags can there be in this state? So, you're going to make license plates. 3 letters followed by 4 digits. How many possibilities are there? One thing you're going to have to know is how many letters in the alphabet.
26.
Yeah, did you laugh about that? A lot of people don't know that.
People don't know that.
A lot of people don't know that, and it's been my experience over the years.
Yeah, that's true.
I know, Monique, you're a language expert person, so 26 letters in the English alphabet. So use that fact. So whenever you're going to choose a letter, you have 26 options, in other words, right? And when you're going to pick a digit, how many options do you have? 10, like we did in the last one, because there's 1 through 9 and 0. There's nothing about not being able to use 0 here, so 10 options for the digits, right? There's 10 digits, and there's 26 letters. So see if you can, if you're at all stuck, even if you're not stuck, it's helpful. Pick one, make a license plate out. Just make one real quick. I still remember the first car I ever had. It's funny how those things just never leave your mind, huh? 365 TVP. Now we only had 3. It was older. I had an old 280Z. It was my first car.
Was that California?
That was a California license plate. Back in the day, they only had 3 digits, 3 letters. It was old. So I'll throw a new, that wasn't really part of my license plate, on there at the end. All right. Had to get rid of the little sports car when I got married, be a responsible person, and get a little money also to pay bills. But anyway, so that was before I was a responsible person. 365 TVPE. So let's just pretend that was my license plate. So I just picked one at random. 3 letters, 4 digits. Oh no, that's reverse, huh? Mm-hmm. Oh, that's weird. No, that license plate's in California anywhere that way. So I'm just gonna I did that backwards. 3 letters, 4 digits. 3 letters. So how about TVP and 4 digits? 1760. So I did 3 letters, 4 digits. I just picked one. Now think back. How many decisions did I make? And for each of those decisions, put a line. For each of those decisions, put a line and put options. The number of options, and then just times these things together. Right? Decisions and options. How many decisions did I make? How many options did I have for each of those decisions? So for the first decision, when I chose T, how many options did I have? 26. There had to be a letter. Next one, 26. Next one, 26. Then I chose digits. Each of these are 10, huh? Just like that. And that's some big number I don't know. It's going to have 4 zeros at the back at least, because of the 4 tens. So what is it?
175,760,000.
Did I hear you right? 175,760,000. That'll cover a lot of cars. And so prisoners that make license plates have to know this math. I'm just joking around. But people in control of the license plates do know this math. They know that they're going to cover the number of cars.
Do you know if license plates gets like recycled after a certain amount of years?
I don't know.
After
Yeah, I
total
wonder.
car?
I don't know. I do not know. I think they would, huh? Yeah. Is that good out there? Is it all good? All right, so that's how many different. So there we go. So I'll let you think about that one. 9 colors, 2 styles. How many different ways can the car be ordered? So what do we do? Yeah, it's just 9 times 2, 18. 18 ways. It's a crooked one there. 18 ways to order the car. Is that good? Is that making sense? Pretty easy, right? Just multiply those together. What crazy questions. All right, for a segment of a radio show, disc jockey can play 9 records. If 14 records to select from, how many ways can the program for this segment be arranged? Let's get okay. For a segment of a radio show, a disc jockey can play 9 records. If there are 14 records to select from, so out of the 14 records, he's choosing 9. Does that make sense? And how many ways can the program for this segment be arranged? So what that means is, let me put that in other words. Out of 14 records, choose 9 and order them. In other words, order matters. Okay. Do you agree with that first off? That what they're basically saying is, look, the disc jockey has 14 records to select from, to choose out of, right? That's his pool of records. And out of those 14, he's going to pick 9, and he's going to arrange them, which kind of implies they care about the order, right? So that's now it's time for the C and the P that we practiced before. Basically, this is the deal. Whenever you do in CR and in PR, the C means order does not matter. And P means order matters. And both of them are out for both. It means out of in choose R. That's what the in choose R. You can say it like choose or pick. It's not really pick, it's permute. But that works. So out of in objects, choose R, or out of in objects, pick R. So whenever you're dealing with, I've got a bunch of things, I'm going to pick some out of it. That's time for in CR or in PR. How do you know which is which? Because the P order matters. The C order does not. Is that making some sense? So for example, they could have said, I could say this, I could say, hey, I'm going to go on vacation. I got 10 books on my shelf I've been wanting to read. I'm going to pick 3 to take on vacation with me. How many different groups of 3 books could I pick out of my 10? Well, that would be 10C3. Because it doesn't matter what order, right? You just pick the 3, throw them in your bag, and go on vacation. It doesn't matter what order you pick them in, which one was first or second or third. Whereas if I say, I'm going to pick 10 books, out of my 10 books, I'm going to pick 3, and I'm going to put them on the shelf in the front room in a certain order, then that would be 10P3 because I'm caring about order now. See the difference? It's still out of 10, choose 3, and you care about the order. So P numbers are going to be higher because you care about the order. There's more. There's even ordering you care about. P stands for permute, which means change the order of. Does that make sense? So you want to have on your 3x5 card, well, for the final, you get a full sheet. That's right. And I should say when the final is, since that's all we got left. Is that what it is? Yeah.
1 o'clock.
Yeah, you guys know the whole story. Yeah. The final exam, I can just write it on our sheet, I guess. Here. So anyways, well, let's finish this problem. Let's finish this problem, then I'll do that. So, okay, so this one now, does the order matter? It does. They're telling, when they say the word arrange, the songs are arranged, they're saying they care about the order. So am I gonna use a P or an N? A P, because the order matters, huh? Order matters, gonna use the P. So that means it's just 14P9. Hit the buttons on your calculator. Somebody got it?
Yeah.
What's the number there?
2002.
200?
No,
2002?
that's not it.
That's for CR.
Oh.
Sorry, you're right.
726,485,700.
760? So there's isn't that it blows the mind. Would you have guessed there's 760 million different ways to choose 9 songs and put them in order?
So if we did NCR, what would we be doing differently then? We'd be taking 9 records and,
Just take the 9 records. Who cares what order?
oh, just throwing them in a pile, basically.
Yeah, just any 9 records. Yeah.
Okay.
Because that's what I was tripping over. You said it was.
Is that good? 726,485. Let me go in. Okay, does that make sense then? That's what they want. So when you read these questions, how are you going to recognize these? Well, when it's out of this group, choose that. You go, okay, it's C or P, and C, the order doesn't matter. P, it does. Permute means change the order of. Permute means change the order of. Right? Okay. So let me stop from that for just a second.
How would you know the difference? You say again?
If the order matters or not. I'll come back to that. Let me talk about the final exam, and I'll say a little bit more about that. So the final exam is, what is it? It's on my sheet here. It's Tuesday, so it's week after next, right? Tuesday, May 16th. So the next week is our last week of lecture. Tuesday, May 16th, 1 to 3 p.m. It's a 2-hour deal. So we'll go 1 to 3, a little bit longer than we normally go. Right here. Yeah, that's the plan. I have office hours are different finals week. Office hours are always different for every teacher in finals week because so there's no class Thursday that week or anything, right? You know how finals work. You just come to your final, that's it, right? Office hours, finals week. So next week I have normal office hours, like 9 o'clock in the morning, like usual. But finals week, I will be there Monday, 9 to 11. That's the day before your final. Tuesday, this is May 15th, 16th. Tuesday, I'll be there 10 to 11 in the morning, a couple hours before your final. And then Wednesday, of course, that's after your final. I don't think you really care much. 9 to 10, and Thursday, 9 to 10 as well.
That Monday and that Tuesday.
Right. Monday for 2 hours, Tuesday. So that's finals week. So yeah, so our final is just Tuesday, May 16th, 1 to 3 p.m. And what you want to do is review the old 3 exams. I will put, I'm scribbling all over the place here. Come on. They will, the old exams, the old 3 exams, I'll put the keys online by next Tuesday, let's say. Next Tuesday, I'll put the keys online. So I'll put them right on online. I mean, right on mathexcel.com. Just you won't have to go anywhere else. We're just, we'll use mathexcel.com for all of our connections to the class. So I'll just put a link right there on mathexcel. I'll probably put it under the announcements. Yeah, I'll put it under the announcements. Right where I put the practice exams. Yeah, the announcements right below the practice exams. So I'll put the keys for exams 1, 2, and 3, parts A and B. So look at those, go back over those, study those. You got a bunch of those, go over those, and that'll get you ready for the final. Final is hard. Again, I want to warn, because just typically there's a lot of bombing going on and a lot of sad people. It doesn't happen, but some people do great. It's those who study more, right? So it's not harder problems, I promise. They're not harder problems at all. They're the same problems as always. I'm not trying to bomb anybody. They are fair. I'm not putting weird stuff. I'm doing just the main things. I mean, you know what's going to be. There'll be one simplex. There'll be one, You know, one of all the main, I'm not putting weird stuff at all. If you're looking at something that we hardly just did real quick, it won't be on the final. It's just the main meat and potatoes, you know, the things we've done. All 3 exams pretty even-handed, you know, just maybe half of each of those old exams, the main things. But it does take review. To just show up to a math final having not studied, just academic suicide. Just absolutely academic suicide. I'm right. You just can't. Oh yeah, get a full sheet. Yeah, full sheet. Full sheet. 1 full sheet of notes, both sides. So you know, if you want to just get your old cards still, just want to put them on there, great. If you want to do whatever you want, I would make that sheet as you go over the old exams. Just anything you need, write it on that sheet.
Are you gonna provide the formulas for like the present value and all that stuff?
I don't know. So I might not put anything on there. Yeah, so just put on there anything you think you might need. Yes, right. So we have all that. The second exam was all that financial stuff, huh? Yeah, so you really have to look back. You really have to look back at all that, amortization and all that. What's hard? You know what it is? It's hard. It's not that you can't do it. If I reviewed with you for 15 minutes, amortization again, you'd all be cranking it out, no problem. But the problem is the final has 1 amortization, then 1 simplex, which is like completely different, and then 1 exponential log thing from exam 1, then 1, you know, that's where you need to practice the mix-up, the identification. Identification is the name of the game on the final, and that won't come to the casual. That will come to those who spend time practicing, and you try to identify the characteristics, you know, oh yeah, that's one of those amortization. Otherwise, you know, I get people when I create the final, I can tell they don't even have any idea where the problem's coming from. They're doing a simplex on a financial thing. You know, they're doing a tableau for me on the financial, and I'm just 0, 0, 0. I mean, I'm not thrilled to give zeros, but I have to hold a fair standard. So you have to review that. That's the state of California wants to know which students, really, it's not my thing. It's not even Fresno City College thing. It's WASC, if you want to blame it. It's the Western Area Schools and Colleges, which accreditates us, you know, that says you will give a final exam that's comprehensive. We have to. Comprehensive final exam if this class is to be accepted at Fresno State and all the other universities. WASC is saying, we want to know who the real students are, who are really university quality students. And that is the cut. It's those who will study in that way. So make that cut. You can do it. Put your time in. Just start early. Don't wait till the night before. You know, start early. Just start going over those exams. Just working through the problems. And you need help, come see me. I'd be glad to help you. Roberto's hours are available. Tutoring center.
Is he gonna do Ram Slam? Do you know?
I don't know. He'll probably let us know next week. That's right. There's Ram Slam finals right before. Should be even late next week, huh?
Yeah, it's like Wednesday and Thursday nights.
Yeah. I don't know if they changed the those people's hours. What they call those people? The ETC people's hours. I doubt they do. Yeah, so he'll probably just be normal. All right, so let's keep moving. Yeah, so about getting back to the PC thing, the permutation combination thing. Let's talk about that for just a minute. Just think, I want this to be real. I don't want to use up too much time. You know, I hate just formula, not real. Just think real life for a minute. If I said, hey, I've got 3 letters, A, B, C, and I want you to pick 2. How many groups of 2? I want to make a really simple problem that we can do by hand. How many groups of 2 letters out of 3 could you pick? Well, you could pick AB, you could pick AC, or you could pick BC. That's it. Right?
Unless order matters, right?
Right. So when I say just groups, right, you're totally right. So right now I'm saying, good point. Order does not matter. Yeah, if they just say group, then you're just assuming they don't care what the order is in the group. So is everybody good with that first off? And that's what the answer we give is 3C, out of 3, choose 2, right? Out of 3, choose 2. If you do it on your calculator, you get the answer, well, not 2. Get the answer 3. Those are the 3 groups. So that's what it's actually done. I want to make this a little bit real for you. To see what it's telling you, it's saying, hey, if you got out of 3 things, out of A, B, C, 3 letters, pick 2. I want to, it's Sesame Street or something. I want to pick my, today is brought to you by the letter A, or you know how they do it. I want to pick my 2 favorite letters, right? Do a Sesame Street lesson, But I want to make sure it's fundamental nuts and bolts for you. That's how I think. Really, when I look at these fancy, when I was doing my master's in math and these fancy complex formulas, this is the kind of thoughts that would get, simple thoughts, understood clearly, allow you to do hard stuff. It really is. It's like that. It really is. So make sure you know, nuts and bolts, basic level, What is that formula doing? The more you're real with it like this, the more you'll be able to do the fancy stuff. So that's what that formula is really doing. When you say 3C2, you're saying out of 3 objects, like 3 letters, pick 2, choose 2, right? Choose the first 2, the first and last, or the last 2, right? There's 3 different ways to do it. Now, how about if we throw the order in there? What if we say, now, out of 3, choose 2, but order them on the shelf or whatever, right? I'm not just gonna pick the 2, but I'm gonna say, and I want B coming first and then A, or whatever. I care about, and that's different than A, B in my mind, for whatever reason, right? There's times in life where we care about the order, and there's times in life when we don't, right? So, if this is a time where we care about the order, how many different ways? Well, it's the same thing, isn't it? It's A, B, A, C, and B, C. It's the same 3 groups, but now we could say or B, A, or C, A, or CB, because those would be different if you care about the order. See how that doubles it, twice as many? And that would be what? Out of 3, pick 2, because it's P. P, order matters. And if you did that in your calculator, it would tell you 6. See, there's only 3 when order doesn't matter, and there's twice as many, 6. And it isn't always just twice as many, it's sometimes a lot more than twice as many. But there's more. The P is always more, because now you care about the order. It's not just, did I get the group AB? Yeah, you got the group AB, and what order did you put it in? Gives you more options. Do you see how that works? So P is always more options. All right, so put that on your study sheet for the final. I have a really silly memory device. I made it through college because I have a terrible memory, and so I had to have little tricks. So here, and my buddy, my colleague used to say this to his students. I thought it was kind of clever. So when you order it stands for combination. Just how many 3 out of 3, how many combinations of 2 is really was. So he used to say to his students, when you order a combination pizza, do you ever tell them the order? Say, I want the pepperoni to go on before the anchovies, or no, nobody does that, right? So combination is no order. That's the one with no order. You never tell people the order for C, for combination pizza. You never tell them the order. Right, the P is the order one. All right, so those, let's see. Okay, Mrs. Welch and her 3 children are shopping in a local grocery store. Each of the children will be allowed to select 1 box of cereal for their own from the 8 different boxes of cereal available. There are no 2 the same. And how many ways can the selection be made? So we've got 8 boxes of cereal. Each of the children, we're talking 3 kiddos. All right. So out of 8, choose 3, right? Out of the 8 boxes of cereal on the shelf, they're going to take 3 home with them, aren't they? The 3 kiddos are each going to pick a box of cereal. Now, so it's going to either be 8C3 or 8P3. How do we know if order matters or not? This is where it gets subtle. Remember I told you this whole course I took at Poly was subtle. Here all begin some of the subtleties. You know, like a mystery that's very subtle, the little clues. These problems are subtle. Let me present it to you this way. Here's an example I found help students over the years. If I was to say, okay, I'm going to pick 3 of you in this room, and I'm gonna give you got my wallet here, there's not a lot in it. I remember one time a student left their wallet behind. It was 15 years ago. And they had a lot more money than me. So I'm kidding, I get it. But I was just shocked. All these wads of 20s, I don't know what that person was doing. But anyway, this is not what's in my wallet. I got 5 kids. There's not much left. All right. Anyway, but I'm going to give a $10 bill. I'll pick 3 names at random out of a hat of you that are in here, and I'm going to give a $10 bill to each of you. If you were chosen, if I chose Josh and Alexander and Monique, would that be different if I was pulling the names? And first name was Josh, next name was Alexander, next name was Monique. Monique, would you be thinking, darn, I was last. I wish I was first. Who cares? You got the $10. But if I instead said, so order wouldn't matter to you. Because why? Because the reward is the same, 10, 10, 10. But what if I said, I'm going to pick 3 names at random out of the hat. First one getting a 20. The next one's getting 10. The third one's only getting $1. Would you care then, Monique? Yeah, so do you see the deal? When the rewards are different, the order matters, doesn't it? That's a way of implying order matters, right? You see what I mean? Does that make any sense? What if, so in this case, so let me write that first off. Order matters when the objects given, the reward I called it, are different from each other, right? So if you have $10, $5, or I think I said 20, huh? 10, whatever, 3 different dollar amounts, that would mean order matters. Because you care whether you're first, second, or third in that picking. You don't just care which 3. If I just said, hey, these were the 3 names, you'd also say, Josh would be like, well, was I first? Or was I third? Am I getting the 20 or the 10? Right? Whereas if you just have, if there were just all 3 $10, then who cares? Order doesn't matter to anybody. Order does not matter.
So they're all getting boxes.
So this would be the NPR. This would be the NCR, right? C is the order doesn't matter. Yeah, so now, so it's out of 8, choose 3. Now, are the cereal boxes all the same cereal? Are they all, whatever it is, Crunch Berries?
There's no.
My kids like Crunch Berries. So unhealthy, I think. Really? I mean, eat something that's, anyway. So, so are they all the same or are they different?
It says there are no 2 the same.
They are different. 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 P8, P3. Order matters because the cereal boxes are different. If they were all the same cereal, it's different. It's different results. So see, it's a little subtle, isn't it? It's, you got to be careful. That's why I couldn't get an A. Subtle. So 8P3. So somebody get that in their calculator?
336.
What is it?
336.
336. Thank you. 336. Order matters. Whereas if they'd said it's all the same 3 cereals, it wouldn't matter. On that. We good there? Questions on that one? All right. Okay, a club with 13 members is to choose 3 officers: president, vice president, secretary, treasurer. If each office is to be held by one person and no person can hold more than one office, how many ways can it be done? Let me give you a second, rather than me just diving in. See if these concepts are starting to make sense. So is there a big pool? And out of that big pool, we're choosing a small amount. So out of what? Out of 13 members. Choose, pick, whatever. 3 to be officers of some kind, right? Now, does, the whole question, does order matter or not? So how do you answer that question? Well, if I said, okay, the 3 officers, just try to be, the more you can be real with this stuff, that's what I really learned in this field. Even though I obviously didn't learn enough, I didn't get an A. But I did learn to make it, the more real I could make it. If I said, all right, I'm going to pick the 3 officers. All right, it's Monique, Josh, and Alexander. Does that answer the whole thing? No, because one of them is supposed to be the president, one's the vice president. They're different offices. They're not just, which is, so the offices are different, so does order matter? Yes, order matters. Yes, order matters because the results, the offices are different, right? They're different. We're talking president, VP, and secretary. Those are different offices. Now, so it's going to be 13P3, isn't it? Not C. Now, probably the next question, I don't remember exactly, but a lot of times they'll ask this. They'll say, 13 members in the club, you're going to pick 3 to be on the board of directors. That would be C, because they're just all the same office. They're on the board of directors, or they're going to go on a trip, or if they're all doing the same thing, then it's just C. They're all the same. But if they're different, that's when order matters. All right, so what's the number 13P3?
1716.
1716? 1716 or 60?
16.
1716, okay. All right, there we go. All right, committee of 4 students is to be selected from 14. So it's same kind of deal, out of 14, pick 4, right? Here we go again. In how many ways can this be done? So don't worry about part B yet, let's just do part A. Committee of 4 students. So ask yourself, are those different results for those 4 students? Is it like getting different amounts of money or different offices? Or is it all like getting the same amount of money, same offices? Man, it's all the same, isn't it? It's not different, right? 4 students, committee of 4, same results, same office. So not different. So what? What does that mean when they're not different? Order does not matter. So is it C or P? In CR, right? Order does not, like a combination pizza. You don't tell them what order to put the toppings in. No order mattering. It's in CR, not P, right? Because it's just 4 committee members. But if instead they said, president, vice president, secretary, treasurer, then those would be 4 different offices, and we would do P, right? Order would matter in that case. So 14C4, somebody have that? 1001. That's an interesting number. 1001. 1001 different ways to pick 4 people out of the 14 to be on the committee. Okay, now, part B. All right, you feeling tricky? This is what I told you. This field is subtle. Here we see some of the subtleness. In how many ways can the group that will not take part be chosen? Give you a minute. The group, do you understand what they're saying? How many ways can the group? Notice when you get to 14 people lined up, there's about 14 of us in this room. I'm going to pick 4, right? I'm going to pick you 4 right here to be on the committee. Now, that was part A. That's what we just did in part A. Or maybe these 4, or maybe these 4, or those 4, right? There's, how many ways do I pick 4? Now, in part B, they're saying, well, instead of picking the 4 that are on the committee, how many ways are there to pick the group that will not be on the committee? Right? You're picking, you say, okay, and you 10 are not on the committee. Right? You're not on the committee. How many ways are there to do that? So what do you think? 14, out of the 14 in the room, choose 10 to not be on the committee. Beautiful. Excellent. Perfect. What do you think the answer is going to be?
1001.
Yeah, it's the same answer. Is that a surprise? If you think careful about it for a minute, you'll see. When you pick the 4 on the committee, by default, you have picked the 10 that are not. There's no difference. But it doesn't, see the subtlety there? Every time you pick a group of 4, you have picked a group of 10 who's not on the committee, haven't you? So every single way of picking a group of 4 on the committee is also a way of picking 10 not on the committee. So every one of the 1001 ways of picking a group of 4 will be a way of picking 10 not on the committee. So we didn't need to do anything but write down 1001 if we were thinking clearly. See how that's subtle? It doesn't hit you at first. That's what's in this field. It's subtle little thoughts like that. To pick 4 is to pick 10. All right, same exact answer. Good one. All right, so we got 10 teachers, 49 students. You're going to pick a committee, 3 teachers, 2 students on the committee. All right, so it's basically 2 of these PC things that we're going to multiply together, 2 of them at the same time. Let's do the teacher one first. How many ways can we pick the teachers? So out of 10 teachers, we're going to pick 3 teachers. Forget about the students for now. Let's just do the teacher pick first up. Out of 10 teachers, we're going to choose 3. Is that C or P? Well, does the order matter or not? Is there anything in there that says the teachers are getting different offices or different awards of some kind? No. They're just on the committee. So it's C, right? Order doesn't matter, like a combination pizza. 10, choose 3. That'll pick the teachers. Now, what about for the students? Same kind of thing, right? Out of 49 students, choose 2. And what are we going to do with these two things? Multiply. Remember, we always times together? Whenever there's more than one pick, like I'm picking my pants and my shirt, you just multiply them together. So it's just 2 C problems multiplied together. That makes sense? Out of 10 teachers, choose 3. Times, out of 49 students, choose 2. Order doesn't matter because they're all just equal offices. It's going to be a really big number, probably.
41,120.
41,120?
141,000.
Oh, 141,120. Can we get a verification on that? Anybody else getting the same number? Yep, all right. There it is. Is that good? Is this making sense? So whenever there's more than one choice going on, right? You're picking teachers, you're picking students, you're picking pants, you're picking shirts, you multiply those together. All right, Janine Baker makes floral arrangements. She has 17 different cut flowers and plans to use 7 of them. How many different selections of the 7 flowers are possible? So out of 17, she's going to pick 7 to put in an arrangement, right? Is there anything in there that says the order matters? I don't think so. It's a kind of a little subtle. You can tell me.
17 different cut flowers?
Yeah, she just plans to use 7 of them. It doesn't say anything more than that, so I think it's just a C. The order doesn't matter. There's nothing in there about those 7 are going to be put from top to bottom or anything like that. It's just a 17C7, some giant number. Whatever it is, that good? There? Let's see here. Okay, so we got ice cream store, 24 flavors of ice cream, 7. Determine the number of possible 7 dip sundaes. How many 7 dip sundaes are possible if order is to be considered? Nice, so they're just giving it to us there. They're saying, hey, let's care about whether it's chocolate, then vanilla, then strawberry, or strawberry, then chocolate, then vanilla. We'll call those different. The order is mattering now. So is it going to be a P or a C? P, because order matters, right? So it's out of 24, pick 7. That's a big Sunday, 7. Out of 24, pick 7. Order matters.
These are like the easiest word problems we've had to do.
Yeah? These are kind of, you guys are probably thinking, how did Mr. Hart not get an A in that class? What's his problem? It's easy.
Did you have a graphing calculator?
No, that was probably the problem. No graphing calculator. That was it. Come on, Dr. Hood. He would have mocked me. He was mocking me all the time anyway. You guys are so It's funny. Anyway. Oh, at junior college, her teachers think she's great and getting good grades. Well, you'll see. Cal Poly's a little different, honey. All right. So, certain lottery, the player chooses 7 numbers from the numbers 1 through 38. How many ways? Yeah, we'll do the lottery thing here. All right. So, certain lottery, 7 numbers from 1 through 38. How many ways can the 7 numbers be chosen? Is that how the real lottery? I don't keep up. What the lottery now? Do you pick 6 numbers? 7 numbers? Nobody knows. What? We'll pretend it's 7 numbers. So right here we're finding how many different. This is the chance you get the right ticket, right? Right? You're supposed to pick 6 or 7 numbers, whatever it is. The California lottery. Nobody knows. Anybody have Google online? But you can't get much in here, can you? Is everything blocked?
No, we have.
Can you get it? Can you get online? What is it? Is there 6 numbers or 7 for the California lottery? I want to know if we're doing the real thing here. And is it the numbers 1 through 38, or is it like to 99 or something? So it's probably different somehow. All right, well, so this is how they calculate the chance of winning, right? Because basically, how many different ways are there to pick 7 numbers out of the numbers 1 through 38?
It's 6.
Oh, is it 6?
The California law.
California is 6. And what range of numbers?
1 to 47 for 5 of them, and 1 to 27 for the 6.
Oh, they change it up.
Yeah, apparently.
So we could do that one, but let's don't bother. Anyway, basically the same idea. So out of 38, choose 7. You with me? Out of 38 numbers, choose 7. It's nothing about order here. They did nothing they said about the order for second, third. They just said the numbers. If they don't specifically imply order, you don't do P. So somebody get that number. What is 38C7?
12,620,256.
That's how they're getting those numbers. When they say the chance of winning this lottery is 1 in 12 million, da-da-da-da-da, that's what they're doing. They're doing those calculations. Not likely. You're more likely to get struck by lightning twice or something on the way to buy the ticket. You know, have you heard those kind of stats? It's kind of funny. So there we go. There we go. Reviewing for the final. I'd like to do more than a whole day of review for your benefit. I'm hoping good results this final. All right. Yeah, here's the special way. We're going to mix up the letters. How many ways are there to mix up the letters in the word Mississippi? Well, there's a simple formula. You can put this on your 3x5 card. Basically, you take the total, this N is total number of letters. How many total letters in Mississippi?
11.
Is that what it is? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the top is 11 factorial. That's that exclamation thing, which is on your calculator. The bottom, you put each different type of letter. In other words, N1, N2 that are down here, you know, that's how many M's. Next, how many, you know, repeated whatever. Right? Instead of M's, you know, repeated repeated I's. Yeah, so M is just, in fact, you don't even need to do the ones. 1 factorial is just 1. It won't do anything. Skip the ones. How many repeated letters? How many I's are there, for example? 4? Yeah, there's 4 I's. Whoops, I'm kind of messing up. So that'd be 4 factorial. That's for the I's. How many S's are there? 4 also, huh? 4 factorial for the S's. How many P's are there? 2 factorial for the P's. And that's all the repeating letters, right? S, I, and P.
Can you just multiply those?
Yeah, just multiply those. So just use your calculator. What's the 11 factorial on the top?
So 39,916,800.
Okay, and then on the bottom, 12, 24. It's going to be 24, right? Times 24 times 2, I believe. So 144, 288, 5 6. It's like, I don't know, 10,000. I don't know, I can't do it.
34,000.
Final answer?
34,650.
Is that final answer or just the numerator or denominator?
That's right. Or final.
Final? 34,000, one more time?
650.
650, is that what you got? There's that many ways to mix up the letters in the word Mississippi. I don't know if you were wondering. There they are. Is that good? So that's not too bad, right? Permutations, so that's just one special formula there at the end. That's for mixing up things that have repeated letters. All right, we've got, I want to spend a sizable amount of time reviewing. So here we go. Average rate of change, 11.3, our last section. Average rate of change for the given function. So we've got a function, and it's saying between 0 and 7. They're going to ask us this question again and again, and almost the whole section is this one question. So it's kind of good if you can just get it down. It's the same thing over and over again. They'll call it by different names. Average rate of change, you know what it means? It means slope. Just think slope. Remember how to calculate slope from your algebra days? y2 minus y1 over x2 minus x1. Remember the m equals slope equals y2 minus y1 over x2 minus x1. Remember slope? That's all they're going to ask us to do again and again and again and again and again. And they're going to do it tricky. They're going to give us graphs. They're going to give us function notation. They're going to give us word problems. They're going to say it slope. They're going to say it in weird words. But every one of these is just slope. They'll call it average rate of change. They'll call it slope. They'll call it other things. But it's slope. And so one thing you got to remember is y values are the same as f values. Remember? Function values are y values. So what does that mean? X is 0 and X is 7, that's my denominator. This is X1, this is X2, so 7 minus 0, X2 minus X1. Good with the denominator so far? Now what do you do on the top? F of 7 minus F of 0. Why? Because F values are Y values. So that's what they want me to figure out. Well, what is F of, am I going too fast? Is that good so far? So average rate of change is fancy talk for slope. Average rate of change is slope. So F of 7 means take this function and plug in 7. You know how to plug 7 into a function, right? Be 7 squared plus 6 times 7. Everybody good there? Minus. And then F of 0 is 0 squared plus 6 times 0 over 7 minus 0. Let me slow down for just a minute. This is our last one anyway. Everybody see that when I'm getting there? So this F of 7 is this right here. That's F of 7. And F of 0 is this right here. And here's the big minus sign between them. This minus sign here. Everybody see that? So this all right here is F, is the function with 7 plugged in. And this all right here is the function with 0 plugged in. So then we just work that out. I'm kind of running out of room here. So let me kind of come over to here, I guess. So this is going to be what? 49 plus 42 minus, and this is just 0, huh? Over 7. Is that good? And that's what, 80, 91 sevenths, and we're done.
But reduces to 13.
What's that?
Reduces to 13.
Oh, does it? Oh. Yeah, you're right. Look at that. 7 times 13 is 91. Who knew? I didn't, clearly. 91 sevenths, and the answer is 13. If you do that on a test, there's no credit. But, you know, if I do it, it's okay. All right, I'll try to be a little merciful. All right, there we go. So we did finish 9.2, and 9.2 will be due on Tuesday. And we'll crank through 11.3, our last section, which we have begun. And then we'll start. So I'm going to